Welcome to the BRONTO YouTube channel. Today I'll tell you about the design, operation, modes, usage and the settings of the BRONTO Extruder E1000. This information will help to enable reliable operation of this machine over many years. Using the Extruder E1000, you can easily reduce the content of anti-nutritional substances in raw materials such as soybean or rapeseed. Plus, you can increase the digestibility of grain feed ingredients and destroy harmful bacteria in plant material. The Extruder E1000 corresponds to the safety requirements of Directive 2006/42/EC for this type of equipment. The extruder is constantly improved and modified to meet client demands. That's why some insignificant changes in its design cannot be represented in this video. Let's get started with the operation requirements. The extruder base plate should be earthed. Make sure you check the earth connection regularly. Disconnect before carrying out maintenance or repair. A magnetic separator must be installed in front of the extruder hopper. Never run the extruder without a safety guard on the V-belt transmission. Never stay in front of the screw section of the outlet hole while the extruder is in operation or maintenance and repair works are being carried out. Never stay in front of the screw section while assembling the nut and outlet bushing. The room for the extruder installation must be equipped with a ventilation system. The extruder must be equipped with a forced exhaust ventilation to extract the steam. The Extruder E1000 is designed for the production of cattle and poultry extruded feeds from the following materials: wheat, rye, barley, corn, pea and soybean. It's operated indoors at a temperature of 5 to 40 degrees centigrade and 80% RH. The extruder consists of the following main units. The base is a wielded construction on which the extruder parts are installed and fixed. The stand is attached to the base of the extruder. The spindle and the hopper with the screw feeder are mounted on it. The spindle transmits the drive motor rotation to the screw section of the extruder. The spindle is designed for long-term operation under a high axial load. It consists of casing, screw shaft and bearings. A hole that is closed with a plug controls the axial gap. A pipe carries the grease pumped by the bearing through the holes closed with the plugs. The grease is poured in and discharged from the spindle body. The grease in the spindle is controlled visually via the grease indicator. The hopper is attached to the stand. The screw feeder is installed inside the hopper. It feeds the raw material from the hopper to the screw barrel. The screw feeder capacity is regulated by a frequency converter. The funnel connects the feeder and screw section of the extruder. It's used to supply raw materials directly into the screw section. Inside the funnel, there's a magnetic trap which extracts foreign metal impurities. The drive consists of an electric motor, a drive pulley, V-belt transmission, a driven pulley, and a safety guard. Stretching the belt can be achieved by placing clamps. The screw section transports, grinds and mixes raw material. In order to control the process temperature, you need to either decrease or increase the interval between the nut and tip. Also, if you change the outlet bushing diameter, this will influence the process temperature. The slicer is installed at the outlet of the screw section. It's used only while processing the grain crops. While processing soy, you don't need the slicer. Inside the slicer, there's a rotating rotor with blades. The slicer base is installed on rotary brackets fixed on the extruder's stand. In the operative position, the slicer is connected to the screw section with the help of a special clip. The water supply system is used while processing corn and peas. It moisturizes the raw material in the screw section of the extruder. It consists of a filter, a needle valve, a manometer, a rotometer, a tap and a valve. The control cabinet is a metal assembly with openable front door which carries the extruder controls and visual display instruments. It's mounted on a special stand. This stand has holes for attachment to the foundation. The control cabinet should be powered by copper wires no less than 70 mm squared in size. The purpose of the controls and displays are as follows. Voltage switch for powering the control cabinet. Stop button for emergency disengagement of the switches. Start button for powering the switches. Extruder start-stop button for switching the extruder motor on and off. Slicer start-stop switch for switching the slicer motor on and off. Feeder start-stop button for switching the feeder motor on and off. Grain supply controller for feeder capacity adjustment. Voltage signal lamp for voltage monitoring. Alarm signal lamp for emergency cases when the extruder motor stops. Frequency display for visual monitoring of feeder temperature. Temperature display for visual monitoring of the temperature of the screw section. How to set up the extruder. Pre-operation stage. First of all, inspect equipment for foreign matter prior to starting the extruder. Check the magnet catcher for any possible presence of metal objects. Check grease availability in the bearing assembly. If there's no grease, clean the drain channel of the spindle. Add grease to the mid-height as shown on the grease level pointer. Now check the electric motor and the gear motor rotation of the feeder. The right shaft rotation is clockwise in accordance with the arrow on the motor surface. Assemble the screw section according to the raw material type you're going to process. Move the slicer aside from the outlet hole of the screw section. How to start the extruder. Moisten the raw material to the optimum moisture specified in the operation manual. Fill the hopper with the raw material. Screw the nut until tight and then unscrew it 4 turns. Using the voltage switch, power the control cabinet. Using the start button, power the switches in the control cabinet. Using the extruder start-stop button, switch the extruder motor on. Using the feeder start-stop button, switch the feeder motor on. Using the grain supply controller, set a value of 7 or 8. Add 0.7 to 1.2 litres of water to the first portion of grain in the funnel, in portions of 0.1 to 0.15 litres every 3 to 5 seconds. The extrudate is discharged from the die. Every 2 to 3 minutes, using the grain supply controller, increase the supply, first to 10, then to 12, 14, and so on. Watch the voltage signal lamp. Continue the supply of raw material until the load increases to 75 to 80 amperes. Tighten the nut 2 turns. Operate for 10 to 15 minutes. Tighten the nut 1 turn. When the temperature of the barrels reaches 80 to 100 degrees centigrade, increase the supply of grain until the load on the electric motor increases to 150 to 155 amps. How does it work? After the extruder starts, it operates in a mode where production capacity, process temperature, and motor current load are all set to their default values. The operator should examine the magnetic catcher at least 2 times per shift. While the extruder is operating, the operator must always monitor the following parameters: main drive motor load, process temperature, water supply, quality of the final product. To get the required product characteristics, you have to maintain a balance between temperature and load on the electric motor. If the temperature of the process is too low and the final product quality does not meet the requirements, set the outlet bushing to a smaller diameter. If you can't reach the desired process temperature, you have to check the moisture of the raw material. The load on the main electric motor is adjusted by feeding the raw material from the hopper. How to stop the extruder. Stop the raw material supply using the grain supply controller. Using the feeder start-stop button, switch the feeder motor off. Stop the water supply. When the final product is discharged from the die, using the extruder start-stop button, switch the extruder motor off. Using the slicer start-stop switch, turn the slicer motor off. Using the start button, power the switches off. Using the voltage switch, power the control cabinet off. Withdraw the slicer to its start position. Disassemble and clean the screw section. How to disassemble the screw section of the extruder. Caution: the screw section after the extruder stops is still under residual pressure and high temperature. Disassemble the lock from the outlet barrel. Disassemble the outlet barrel with the nut and the outlet bushing. Disassemble the tip. Disassemble the barrels. Install the ring instead of the outlet barrel. Fix the ring with the lock. Install the washer. Screw the bushing of the puller onto the extruder shaft. Insert the beam into the base slots of the puller and ring and fix it with the pin. Jack the ring and remove the next barrel. Disassemble the screws. Screw the ring onto the end screw. Screw the bushing of the puller onto the extruder shaft. Insert the beam into the base slots of the puller and ring and fix it with the pin. Jack the puller and remove the screw. Now you know more about the Extruder E1000's design, pre-operation, startup, and how to operate and stop this machine. I hope this video was useful to you, and stay with the BRONTO YouTube channel.